functions are usually written with this base in mind. Every textbook's different, so you might call this A, and then maybe this will be B, X, that's supposed to be an H, not a B, minus H plus K. Your textbook might call this K, that A, it just depends. These are the stretches and compressions and movements. So A and K always deal with up and down. K deals with moving the whole thing, so it's a transformation, up or down. And A deals with stretches. Stretches up and down. So this is stretching up and down, this transformations up and down, where B and H deal with the horizontal. Okay, B deals with the stretches horizontally, and H deals with movements or transformations. Okay. Okay, so does that make sense to start with?
Yeah.
Okay, so because of all those variables, depending on the function we're with, it kind of changes the way it looks. So our linear functions are f at x is equal to x. Okay, so this is really straightforward. This is essentially it with a linear function. The only thing is we can really simplify such a linear function. Okay, it would literally be written like that. A, B, x minus h plus k. In the end, when you simplify it, it ends up being when it's like this function is usually written as f at x is equal to y equals, f at x is to y, is equal to mx plus b. Does that make sense? When we can always simplify these. If we have a number for a, b, h, and k, we can simplify it into mx plus b form.
So the a is always like affects the y's or the x?
The y's.
The y's?
Yeah, up and down. So it's stretching it vertically.
Okay, you know when this is stretch or compression.
Okay, technically b's are backwards. So if it says it's compressed, so let's give you some rules to these. First of all, A deals with if it's stretched. Does that look right?
Yeah.
If it's stretched, then it's a number, so A is greater than 1. That deals with stretching it. So like a parabola, when A is greater than 1, it gets stretched. If it's compressed, that's when A is between 0 and 1. So A is greater than 0 and less than 1. So that's when we get fractions. Okay? And if A is less than 1, it's a flip on the y-axis. Okay? What's the next one we have?
So
now,
it's for the y's, right? So do you multiply or like divide it by the number?
What do you mean? When B is stretched and compressed, it's a little different. B, a stretch, is when A is between, not equal to, when it's greater than 0 and less than 1. So it's the opposite for B. When it's stretched vertically, or horizontally, that's the wrong word, and when it's compressed, it's the opposite. That's when A is greater than 1. Okay? Always think of our horizontal ones as being the opposite. Remember the same ideas with H, we're moving it left and right? That's always opposite. So A and K are always whatever you think it is, it's logical. So if you're moving up, it's positive. If you're stretching it, it's a greater than 1 number. If you're compressing it, it's a fraction. And if you're going down with K, it's negative. With H, it's, if you're going left, we're talking positive. If you're going right, it's negative, so those are opposite. If you're stretching it, it's a fraction. And if you're compressing it, it's like a whole number of 2, something like that. Does that make sense? So the inside ones are opposite of what A and K would be. Does that help a little?
Yeah.